Hi everyone, and welcome to our probability methods revision course or revision topic. So we are going to be going through all of the fundamentals, all of the concepts you need to know for the examinations at the end of the year. So let's dive right into it. For our agenda today, we're going to be talking about three topics: the normal distribution, probability trees, and probability tables. The exam is actually split into those three categories. But before we're going to start, I would like to talk to you about efficient learning strategies. It is very important that you use your time very wisely, especially so close to the exam dates. You need to study for all your subjects and revise so many notes. So let's talk about how you can do that most effectively. Make sure you stick around, because at the end of part 3, there will be a surprise waiting for you. Majority of the concepts that we will be covering in these 3 videos will completely cover the material that you're supposed to know. So after that, you'll be ready to do some past papers and get ready for the exam. Now, so that you're ready for your videos, make sure you've got your pen, paper, and a calculator with you so that we have everything that you need. We will be using the calculator quite a bit for the normal distribution, so make sure you have your graphics calculator with you so you can go along with the questions that we're going through. For today's goal, we are going to review all of the concepts that you should know. Make sure we prepare you for the exam that is upcoming and give you the best shot at going doing well. Make sure you take notes. Everything that you're not sure about, pause the video, take some notes, have a look what you might or might not have learned or remembered from school. Once you're ready, let's go. Just a quick introduction about myself. So I am Marcel. I am a math and stats tutor, and I have been for almost 12 years. And I have taught these topics over and over. And I actually started my own tutoring business where we focus on one-on-one tutoring, and we specialize, of course, in mathematics and statistics. If you require any more help outside these free lessons that I provide for you, you can always get in touch with us, and we can sort you someone who can identify the problems or the concerns that you might have with the exams. So let's talk about the pre-topic, effective learning strategies. How are we going to do this? Let's have a look. One part that is really important is active recall. We want to make sure that you are always recalling, going back through the notes and actively using your memory to get to the information. That means when you are going through your notes and you're revising, make sure that you turn it upside down, blank it out, and think what was on that paper. Try and memorize it. Try and replicate what was on the questions or on the notes by memory. Once you've completed past papers, same thing. You look at the answer, you go back to the question, you turn over the page and you think, why did I use this concept? What did I not understand about the question? Where was I stuck? And I'm kind of also already going into the ask yourself questions part, self-talk. Talk to yourself in your mind, mentally have a conversation with yourself to make sure that you know what you're doing. Repetition is key, so it is much better if you do a few minutes of studying every day, but consistently. If you're revising your notes for 5 minutes every single day, you will have learned more after a week or 2 than in a full 4 or 5 hour study session. So let's get into it. For our first topic, sorry, excuse my dogs. So for the first topic, let's talk about the normal distribution. So the fundamentals that we need to talk about is what is the distribution in general. When we have a distribution, we want to actually show us how the picture of our data is looking. What possible values do we have? How does it look? Usually we can do like a histogram, or we can do a bar graph, depending on what our data is, what our variables are. So, but But we need to identify a few key points whenever we look at a distribution. We look at the shape of the distribution, the center, so mean, median, potentially mode, and we also want to talk about the spread. How far apart is our data? How much is it varied over the whole range? So here's just a few distributions. You probably have seen a couple before. For example, the uniform distribution just at the top where everything is the same. Or a very common one is the skewed distribution. There's a lot of skewed distribution, the geometric, the exponential distribution, they're all skewed, the chi-squared distribution. Now, we're really going to only focus on one, which is going to be the normal distribution. But just keep in mind that there are more than just a normal distribution out there. Let's have a look at the normal distribution. When do we use the normal distribution and what does it look like? You should by now hopefully have remembered that the normal distribution is bell-shaped. We can see the picture right over here, what it looks like. So let's talk about a couple of key features. The features that you should know is symmetric. We have a very symmetric curve where we have the center of symmetry right through the middle. That means that if we were to flip it around that point, we would exactly get half on the other one. It will be on top of each other. Another important part is when we talk about the center, just like we discussed, we talk about mean, mode, and median. And in the normal distribution, all of these are the same. We can also see that it's unimodal. We only have one peak. It's bell-shaped. This is what we call this kind of curve. Be very sure that right at the bottom, it never touches the x-axis. It gets ever so slightly to the x-axis, but it never actually gets to equal to 0. Yeah, this goes infinitely into both ways, but it will be so close that we can consider it basically 0. Now, because we want to talk about probability, we need to make sure that this normal distribution has a total area of 1. And we will see that in a little bit, why that is so important. So every distribution has got parameters. Parameters are like input points, input information, things that you can put in. We have our general bell-shaped curve, but we need to be able to move it around, adjust it slightly depending on our situation. So this is where our parameters come in. We have two parameters for the normal distribution. One is the mean and one is the standard deviation. So, how do these actually change our normal distribution? Let's have a look. Here's a photo of some probability density functions you can think of. You can completely ignore what they're called. Yeah, these are your normal distributions. Yeah, we can have a look here. The blue graph has a mean of 0, so we can see it's centered around the 0 mark. And here we are using sigma squared. Yeah, this is the standard deviation squared. You can ignore that as well. Basically, we want the standard deviation, which is just the square root of each of these numbers. Yeah, but what we really want to have a look here is that the blue graph has a very low variance. So the standard deviation will be lower. That means the data is very close to the mean. It will be close to the middle. However, if you look at the yellow graph, for example, our standard deviation or variance is much further away. So that means we can see a much bigger variety of range. The range is much bigger. Yeah. If we look at the green graph, we have the mean is -2. That means on the graph here, we can see that it is shifted left because the mean is now -2. So this is how these two parameters change the normal distribution, and we can adjust it to whatever situation we have in our real example. So if we have a look here, just a quick reminder, if we change the mean, that means the center of symmetry will be moved. Yeah, it's maybe a little bit unclear, but here we have 0 in the middle, and here we have 2 in the middle. So what happens with the standard deviation? If we look at this graph here, we can see one of them has a low standard deviation and one of them has a high standard deviation. Now, the standard deviation tells us how far apart our data is, how much variance we have. So here, our data seems to be looking at values between -4 and 4. But with a higher standard deviation, we're looking at numbers between -40 and 40. So overall, the data has been spread out much more. And we will see that in more of the pictures later. Just a reminder, the mean is how you measure a center, or it's one way of measuring the center. Different names for this is the average or the expected value, which you will see all the time, and you will most likely find different terms in your examination as well. So how do we calculate it? The mean or the average, we just add everything together, x1 all the way till xn. That's all of our data. We add it together and we divide by n, which is the number of things that we have, the number of observations that we have. So the standard deviation, it will be provided to you most of the time. There is a question where you might need to calculate your standard deviation, but generally every question will give you the standard deviation. And just remember that the standard deviation shows us how far away our data is from the mean. When we talk about the standard deviation, and this is quite important to remember, especially for the higher mark questions, understanding how the normal distribution works will more likely give you higher grades. So we have something called the 68-95-99.7 rule. And what that means is that if we draw our normal distribution, we can make a line through the middle. And then on each side, we have 3 lines going down, each 1 standard deviation away from the middle. And if we now look at this graph over here, we can see that between the middle, -1 standard deviation and +1 standard deviation, so 1 standard deviation away from the mean is 68% of our data. Majority of our data is between 1 standard deviation lower or higher than the mean. If we go 2 standard deviations away from the mean, then we actually get 95%, a lot of the data, basically all. However, if we do 3 standard deviations away, and this is the most that we do, then we get values of, that cover 99.7% of our data. So basically, if we are within 3 standard deviations to either side of the mean, then there should not be any other data out there. It's only 0.3%. There's not much data. So this will become very important when we talk about the spread of a normal distribution. So keep that in mind for our coming questions. You need to be able to sketch this for any normal distribution. So let's see how easy that is. We want to just sketch the normal distribution. Do your bell-shaped curve. Draw 3 horizontal lines on each side of the mean. So you start with the mean right through the middle, 3 lines on each side. Try and make them look that they're almost about the same distance away. And then we're just going to calculate the values. We're going to take the mean and we're going to add the standard deviation. That's the next value. Add the standard deviation again, and that's the next value. So let's have a look. We're going to start with the mean in the middle. The mean is 5. And here I'm giving you that the standard deviation is 1. So I have now drawn 3 lines to either side of the mean, and we're just going to add a standard deviation. So we're going to add 1 to 5, and then we're going to subtract 1 from both sides. So here we get 6, 7, 8 because we added 1 each time, and 2, 3, 4 on the left-hand side because each one we subtracted the standard deviation, which is 1. Now, when we talk about the 3 standard deviations away, you don't necessarily need to remember that that's 99.7% of the data, but you should remember that if you're 3 standard deviations away, that is basically everything. So here what we can actually say is that our data has a range from 2 to 8. Yeah, the range is 6. It starts from 2 and goes all the way to 8. Every data point, everything that we have should be in that range. There's a very, very low chance of anything being outside this number. So this is actually what we call the range of our normal distribution. You can also do this with the 95% range, which is the 95 rule. Here we talk about 2 standard deviations away from the mean either side. So 2 standard deviations away would be 3 all the way till 7. Now again, 95% is quite a lot of the data, so we should have basically a lot of our data in there. There should not be much data outside this range. In the exam, you can use either those two to answer your questions when you talk about the spread of a normal distribution. The 68 rule works similarly, but that's not what they want to see in the examination. They want you to see these higher percentages. So when we want to compare distributions, there's always going to be a question where you have to compare the normal distribution to a different distribution. They might give you actual data which is shown to you in a histogram, maybe some other graph. Yeah, so we want to see if that is actually a normal distribution. There's 3 things that you need to consider to talk about: shape, center, and the spread. Let's talk about each of them one by one. You first go and you put shape, and you talk about all the parts in the shape that you want to look at. We want to look at the symmetry. Is the data that they gave you symmetric? Well, the answer is either yes or no. Let's assume this is the data they gave us, and they asked us, is this a normal distribution? Well, we're going to say, well, let's talk about the shape. This data is not bell-shaped. It is unimodal, but it's also not symmetric. Symmetric and skewed data, so moved all to one side, is the opposite kinda. So here we would say, no, this does not look like a normal distribution because it is not symmetric, it is not bell-shaped, and we're kind of okay with unimodal. Let's talk about the spread. Well, we're going to use that rule that we've just looked at. 68 is not going to be the one that we want to focus on, but 95 and 99.7. So what we're going to do is we're going to sketch the normal distribution, we're going to put our standard deviation on both sides, and we're going to find what that range is. Yeah, for the 95% or the 99.7%. So then we're going to go and have a look. Well, here's my data. Does the range fit? So let's say our range that we actually got was -2 to 3. Would you say that this graph would fit the spread for a normal distribution? Well, the graph seems to be going from about -2 to about 4. There's some data, a tiny bit of data is allowed outside this range. But if we look at -2, there's quite a bit of data out here. And then if we look at 3, 3 is about here. So all of these here at the end are also outside this rule. 99.7% is quite strong. So I would probably say it's close, but it would not quite be exactly the standard deviation that they have given us for the normal distribution. If we look at the 95% rule, we would have to see what the range is to compare this. But we're again looking at the outside, the parts. Where is data that is outside our range? Is that reasonable to assume that the data that's outside is 0.3%? The third part that we want to talk about is maybe the center. So if you're able to actually compute the mean or the median for the data set that they have provided, or maybe they gave it to you, then you should comment on it. Remember that the median, the mode, and the mean are exactly the same in the normal distribution. So is that the case in the data? Calculate each of them and then comment, yes, they are the same, so I'm happy with the normal distribution. Or, no, they're not the same, I'm not happy with this being a normal distribution. In skewed data, which we've kind of seen before like this, we're going to get that the mean and the median are not going to be the same. The extreme values, which are on the right here, they're going to pull the mean towards the right-hand side. So the mean is going to be higher than the median. So, you can also check if the mean that you calculated from data is actually the mean of the normal distribution that you want to use. So let's talk about probability with normal distribution. Everything we've learned so far is for some of the higher concepts. A little bit, you need to be able to understand, to comment on the normal distribution. Everything that we're going to cover now is basically how we're actually going to use this to find probabilities and to answer some questions. So the first thing we need that the area under the curve is 1, and remember we're dealing with probability. So it must be between 0 and 1, which is exactly what we have. The area under the curve actually represents the probability that we're looking at. We're going to see that in a moment. We're going to color in some bits. We're going to shade in some parts of the normal distribution, and the area is actually the same as the probability. This is why we created the normal distribution to fit our probability theory. So with the normal distribution, we cannot make a statement, what is the probability that someone is 1 meter tall? The probability that x is equal to a value is not available. It is always 0. But it doesn't matter, they're not going to ask you for that. I have not seen it yet, but you should remember that we're always going to be asking statements in this form. So remember that this statement means the probability of x between a and b. Yeah, so if we have this form, that means x is between a and b, larger than a, smaller than b. And this notation, we have that probability that x takes on values less than some value b, and x is greater than a. Now here you can see both of these use less than signs, and here I included the equal part. Now for the normal distribution, it doesn't actually matter. You can use either one. You can use the less than and equal sign. You can use the less than sign. It doesn't matter. It's all the same. So the probability under the curve, again, is bounded between the boundaries a and b. Yeah, this is what we're looking at. Okay, here we've got our first normal distribution. Our probability statement is the probability that the random variable x takes on values between negative 1.5 and positive 1. So if we look at our drawing, we can see that the area here starts at the bound minus 1.5 and ends at 1. This is how we do probability for between two values. The probability that we are between minus 1.5 and 1. We can also do the probability that we are less than 0.5. Again, it doesn't matter if you include the equal sign here. So we're going to draw a line at 0.5, and we're going to color in everything that is less, and that will represent our probability. But how do we actually calculate this? Well, the normal distribution has a big formula. It is quite hard to do it yourself, so there used to be a table that you can use, and you still have it in your formula sheet. I highly recommend not forgetting your calculator in the exam, otherwise you'll be forced to using the table, which takes a very long time. The calculator can actually do everything. It skips so many steps, so if you don't have a scientific calculator that can do this, make sure you do for the exam. Okay, let's have a go at some of these. So the height of a year 10 student is normally distributed, So we have the height of a year 10 student is normally distributed with a mean of 155 and a standard deviation of 8 centimeters. So remember, the first thing that we're always going to do is we're going to draw a picture. Yeah, try and get better at drawing those normal distributions, and remember they're not touching the x-axis in your drawing, even though they get so close in the picture it does look like it. So here we are told that the mean is 155. So we're going to make a line through the middle and write 155. We're going to write that the standard deviation is 0.8 in the corner, and we're going to keep that. Now in your picture, these values at the bottom are not going to be there. You are not going to be able to, well, you can calculate them if you add or subtract the standard deviation, but this will not be needed for any of these questions. Just do the line in the middle with the mean. So, what is the probability that a randomly selected Year 10 student is between 143 and 165 centimeters tall? So we have a between question, so we're going to mark 143, which is round about here, and 165. Now in your graph, it doesn't actually matter really where you make this line. The only thing you should remember is that 143 is less than the mean, so do a line anywhere here, and 165 is higher, so do a line anywhere here. The best thing would be to actually write this probability statement, but it's not required for the marking schedule at this point. Now, we have now drawn our two lines, and we're shading in the inside of this because we want to know the probability that x is between those. And this is all we need to do. We have to, however, draw a picture like this in order to get the mark, because the calculator can do everything else for us. So we get that the probability is 0.8275. So how do we actually get that in our calculator? So let's have a look, and let me show you. So you should be able to see the calculator now. So let's have a look. If you go into menu and press 2, usually it's 2, you want to go into the stats menu, and it will give you a table. We're not actually going to use this table. You can delete all the information that's in there. That's fine. What we do want to look at is we want to go to distribution. So in my case, this is F5. Now we want to choose the distribution. Remember, there were quite a few in the beginning, but we want the normal distribution. So we're going to press F1 for normal distribution. And we're going to get 3 options. It is very important that you remember which one you want. If you're calculating a probability, you will need to remember it is NCD. Do not use NPD. We will use the inverse normal button afterwards. So we have to press F2 here for NCD. Now, always check that the data is coming from a variable. We don't want list. So if you have list, make sure you press F2 for variable. Now we're going to see lower and upper limits. And these are the limits that the question wants. This is where we're interested. The lower limit is 143. All right, so we have the lower limit being 143. The higher limit is just as easy. This would be 165. And now you have to remember that this little sign here means standard deviation. It's called sigma. You don't need to remember that, but this sign means standard deviation. So we could go back and have a look. I think the standard deviation was 8 centimeters for this question. And the mean, yeah, we might have to go back. I forgot what the mean was. So we had a mean of 155 and a standard deviation of 8. So let's put those in. And now we're going to press enter, and it's going to give us some information. It's going to give us the probability that we're looking for, and that was exactly the number that we saw on the screen. The Z values at the moment, you can ignore them. They will not matter right now for this question. They are for calculating this if you did not have, if you did want to do medium steps in between, which we don't really want at this stage. So just P for probability. Be careful about negatives later on. When we do use the Z values, they're very small on the calculator. Okay, so we have answered this question. This is the next question. Try and have a look at what this question wants. What is the probability that a randomly selected year 10 student is taller than 170? Well, as a probability statement, this would mean that X is greater or equal to 170. Now, it says taller, so strictly speaking, it should be less than without the equal sign. But again, for the normal distribution, it doesn't matter which sign you use. So again, we're calculating a probability. So let's go back to our calculator. We still are in NCD. So let me get rid of these two numbers. I can't, that's okay. Now, the standard deviation is still 8. We haven't received any information that the standard deviation changed. Also, the mean is still the same. What about the upper and the lower limit? Here we're kind of getting a lower limit. We're getting that we have to be 170 or taller. However, we need to put in a value for the calculator for the upper value. If you remember how to calculate the range using the 3 standard deviation above, we can kind of remember 155 plus 8 plus 8 plus 8. That is going to be kind of our upper limit. But you don't have to do any calculations for this. You can simply just remember that if there is an open end at the top or the bottom half, we just put in really high numbers. So just type in some 9s. It doesn't actually matter as long as it's big enough to be 3 standard deviations away, which in this case already 200 would be. So now we're going to press enter and we're going to see our probability for the final answer, which is 0.03. Cool, let's have a look. Here's the picture. Yeah. So again, we draw the picture where we put the mean in the middle. Then we looked at 170. It's on the right hand side, and then we shaded in the bit that was much larger, everything that was taller. Wonderful. Now, let's have a look at the inverse normal. We've used the NCD button a few times. Now we also need to use the inverse. The inverse will be used if you already know the probability, but you're looking for value. You're looking for some information that is not probability. So if you read a question like this, 10% of the tallest students are invited to play basketball. What is the minimum height for someone to be invited? We have a probability already, so we do not want to calculate any more probabilities using NCD. We're going to go and draw a graph again, just like before. We're going to draw a normal distribution. You should do your line through the middle for the mean at 155. And then where is the tallest 10%? Well, the tallest starts at the very top and it covers everything into infinity. So the right tail. Now, where you actually make that line for the 10% mark doesn't really matter. Make it seem like it's making sense closer to the tail. That's okay. Any line to the right-hand side of the mean and then shading in the tail will be enough. Do, however, when you color it in, write down a line that shows you that you know that the probability here is the area. So 0.1 comes from our 10%, and this is the area here. What we're really interested in is this part here where the question mark is. We want this value. What is the height where 10% is above? So with other words, we're finding one of these values on the X line. Usually these are called the X values. You're finding an X value. Later on, we will also find Z values and we'll see when we call it an X value or a Z value. So let's chuck this into the calculator. How do we do that? Well, let's go back first of all to our normal menu. And if you remember, distribution, normal distribution, and now we never use this one. We use NCD to calculate a probability. And if we want to, if we have a probability and we want to find a number, we use inverse normal, which is F3 on my calculator. Again, make sure you're on variable, but now mean and standard deviation is already in there, which is perfect. Yeah, these are easy ones to put in. Now, what about tail and area? Area, remember, is the probability that you're given. So in this case, 0.1. And now we just need to tell the calculator, where is this probability? So our options are, is it on the left, which is all the way there? Is it on the right, all the way at the tail? Or is it around the middle and the ends are not included? Now, in this case, in our picture, we've drawn the right side, which is everything the tallest. So we're going to click F2 for the right. The tail, the part that we're interested is on the right-hand side. Cool, let's say, let's press enter and see what we get. So now it tells us that X inverse is equal to 165. If you look at our graph, it kind of makes sense that 165 seems to be the smallest or the lowest height, the minimum height for you to be able to go and play basketball. Yeah. Awesome. So we have another question. Sometimes, remember I said you might not have the standard deviation, or in this case, actually the mean. They will give you a question where you have to work out what the standard deviation and what the mean is, assuming that we have a normal distribution. I'm going to give you a 4-step guide on how to answer one of these questions, which will always be at the higher end of the marking schedule. As long as you remember all of these steps, this will be a question that can push your mark, even if your understanding might not be 100%, as long as you follow the steps. So, as always, we're going to draw a picture. That's our first step. Then what we're going to do is we're going to copy that picture and we're going to draw a second one just like that one, with one difference, that our parameters are different. Our parameters need to be 0 for the mean and 1 for the standard deviation. The reason why we can do that is because we have a formula on how these are related. And what we're doing, we're standardizing what our information is. Now, our third step is the inverse normal, just like we calculated just now, to find a z value. And step 4 is the equation to solve for a missing parameter, which is actually given to you in your formula sheet. Z is x minus mu over standard deviation. Now, that seems very hard to do. Let's do an example. And if you follow the same procedures each time, you will be able to do this easily. So let's focus on step 1. Here, doing the dishes, takes me on average 8 minutes. 25% of the time, it takes less than 7 minutes to do the dishes. I want to find the standard deviation for this distribution. So again, we can see we have to do these steps because we're asked to find a parameter. Yeah. If you're looking at a question and you don't know what to do, think about what the question wants and then what we need to do to solve. So first of all, let's draw it. What do we always do? Bell-shaped curve, line through the middle, put down the mean, which is 8. We are also given the information that 25% it takes less than 7. Now we have already got that 8 is in the middle, that's the mean. 25% is less than, so it's on the left-hand side of the graph. And we actually have the number 7 sitting right by the 0.25. Now, usually we write our standard deviation in the corner, but of course in this case, we don't have it. Nothing new here, everything, we've done this before. Remember what step 2 was? We're going to take the same graph, we're going to make an exact copy, we're just going to change standard deviation and the mean, and that's it. Easy as that. We've got a second graph. The first one is exactly the same. The second one, we wrote standard deviation is 1, the mean is 0, and we still have 0.25 as our left-hand side. Now, what we're going to do is we're going to use this second graph just to calculate the z-value. And we always need to use the inverse normal, which makes sense because the other option would be to calculate a probability, but we've already got one here. So let's put that into the calculator and see what we get to. So again, we want to be in the inverse normal tab. Where is our tail? Well, the tail on this side is on the left. What about the area? The area here is 0.25. Just for your information, if they give you 25%, you can actually type 25% into the calculator. And of course, when I show you, it doesn't work. But over 100 would be percentage, then it will calculate the 0.25. Now, the standard deviation and the mean, we have to use this from our second graph because we have to put them in order to get a value. And that's why we do our second graph. So the standard deviation is going to be 1 and the mean is 0. And we're going to press enter. And again, be very careful. This minus sign is often forgotten because it's so small. Now, for the second graph that we create, that is where we call it a z-value because it's a number that we just temporarily receive, that we just calculate to continue from there. After that, we don't need that whole graph anymore. So let's write down that number and see what we get. Oops. So, yes, this is just calculating the z-value. So we got minus 0.6745. And we can see here where the z-value is. It is the line where our area starts or ends, depending on which side you're on. Now, the last step is we need to use the formula. And what we need for that are values z, x, mu, and sigma, the standard deviation. One of them is going to be missing. So write down the ones that you've got. So we have z in this case. We have x, we have the mean, and we want to find the standard deviation. If you forget the formula, that's okay. You can find it on the formula sheet. If you go to that big table, it will have on the top the formula z is equal to x minus mu divided by sigma, the standard deviation. Now, write all of your numbers down. Substitute them into the formula, and now we need to do one tiny little bit of algebra where we rearrange this equation for sigma. And if you've done this a couple of times, it's always the same step. So we're going to move sigma to the other side by multiplying. So we're going to multiply by sigma, which moves sigma to this side. And then we're going to divide by the number that we have in front because we want to actually just have sigma on its own. Once we've done this here, we can see 7 minus 8. That was just leaving us with minus 1. We calculated that after sigma was moved to the other side. And then we have our final answer. So the standard deviation for doing my dishes is about 1.48. If you're calculating the mean, there's just a slight difference because you would have the standard deviation at the bottom, but at the top, the mean would be unknown. So you would multiply by the number that's on the bottom, just like here as well, but this time you would calculate this and solve for the other variable. I'm sure you can do this one step. Okay, so, and that leaves us with topic 2. This will be in the second video. I will see you in the next video.